Okay, folks, why don't we get going? First of all, let me just introduce myself. My name is Bob Flynn. I'm an instructor here at Palo Alto Networks. I've been with Palo Alto Networks now for about 8 years and been able to see our product suite and our platform grow exponentially. I mean, back when I started, we had a firewall, a next generation firewall with App ID. And we came up with a centralized management platform for multiple firewalls to be able to manage those through a single pane of glass. And we've come up with a bunch of other products in our platform since then. Well, the one we're talking about in this series of webinars is Prisma Access. Prisma Access has a few different solutions involved with it. The idea is we have a solution for people in small branch offices, storefronts, that sort of thing, which we call our remote network solution, which allows us to be able to put basically a firewall pan OS up in the cloud, close to where a small remote network or branch office might be, in order to provide security for users without having to backhaul them all the way across the country, across the continent, across the world to a centralized data center. There's also the idea of mobile users. Users sitting at home, sitting in a hotel room, sitting in an airport that need security and need internet access and need to be able to reach corporate services and things like that. And so we have the ability to do that. If you're familiar at all with our Global Protect solution, it's sort of a cloud-based version of that. And now we have a secure web gateway, which allows users that used to be using an on-premise explicit proxy or web gateway or some sort of a web proxy to do a cloud-based version of that, where again, we can get it closer to the user, give you consistent security, because all of these components have the ability to deliver security with allow and deny rules for security policy rules, for threat protections and wildfire and all of those sort of things based upon the licensing that you do. This week, we're going to be talking about best practices for routing with Prisma Access. And we're going to kind of go through some other routing considerations, as well as routing examples. If you have any questions during the presentation, there is a Q&A button. Feel free to type in any questions you might have. What we'll do is we'll defer those to the end of the presentation, and we'll spend a little time answering those questions. But feel free to type them in as we go. Then at the end, we'll take care of them. So what we're going to be talking about today is first a little overview of the default routing, the way that Prisma Access performs forwarding between the different nodes out to the internet, that sort of thing. We're also going to end up talking about a couple of routing modes that we support that could give you different results and give you different options depending on what your customer might want or you might want. And then we'll talk about traffic steering, ways to basically override the default routing in Prisma Access through either different default routes or using traffic forwarding rules. If you are familiar with our on-premise firewalls, what we call policy-based forwarding, or you may, if you're used to other vendors, you may call policy-based routing or something along those lines. But we'll go through all of that over the next a half hour or so. So Prisma Access is going to provide you with fault-tolerant routing and VPN tunnels within the Prisma Access tenant. So all of the different nodes and all the different pieces and things like that you onboard and put into Prisma Access, we form a full mesh with all the different remote network security processing nodes and service connections. And as we add MUSPNs for mobile user SPNs and things like that, we add this too. This dynamic routing is deployed internally in the cloud for routing, and eBGP is used to peer with the customer on-premise equipment. So this is going to provide you with a complete fault-tolerant solution for routing among all the different components within Prisma Access. Also, remember that all of the nodes, the CANs and the RNSPNs, the MUSPNs, things like that, are actually deployed with fault tolerance, with high availability in active passive configuration. And when we're talking about service connections, and again, depending upon your licensing, you're going to have these different options available. We'll go through licensing quickly as a review here in a minute. But depending upon your licensing, you may have service connections, which terminate to a SC CAN or a service connection corporate access node. And the idea is if you have multiple corporate access nodes, multiple service connections down those SC CANs, users, in this case, remote users in a branch office, are going to connect down the closest available corporate access node down that service connection to reach whatever service that they might need in a data center. You know, maybe it's LDAP or DNS or an internal website or whatever the case might be. And excuse my poor writing, I'm writing on a screen here. But in any case, the idea is that we can have these corporate access nodes. And if you have those based upon your licensing, you're going to have the ability to have redundant ones. Now, if you have a local licensing scheme within one single region, say North America or Europe or ANZ, if you have the enterprise license, you're going to have two of these. So you can have a primary and a backup. If you actually have licensing for our global license, which includes multiple regions, whether it be 2, 3, 4, up to the 8 that we support, you're going to have 5 of these different service connections and these service connection corporate access nodes, these CANs, that are going to be available to you. So you have the ability to actually even cross between regions to a backup if needed. So let's say we have a user in a branch office, a storefront, whatever it might be, within a remote network, a client here that needs to reach, say, an Active Directory server in a data center. Well, if there's a primary and a backup, if the primary fails, well, actually, let's do it this way. Active Directory over here, and the primary fails, we can go to a backup. It would remain regional unless there's no option within a region, and then we'd be able to cross regions. So we'll go to the closest available one. And of course, your data centers may have some sort of BGP solution. They could have some sort of a distributed load balancing solution, or whatever the case may be, that can aid in this sort of thing. Mobile users. So now I have a user sitting at home, trying to reach some sort of a service, again, say Active Directory, in an existing data center. Would hit a service connection can and go down that service connection and get to that service that they require. Again, this is going to follow that same idea that a mobile user, as well as a remote user that we just talked about, is going to hit the closest service connection, the closest corporate access node, down that service connection to reach that service that they need. And again, if there is some sort of a failure, well, we can go to the next closest one. And again, if you have the global licensing, it could even be in a separate region. And maybe we use BGP conversions or something like that to accomplish this. So when we start putting this all together with mobile user security processing nodes, portals and gateways for mobile users, gateways, which we would call the MUSPNs when we're talking about Prisma Access. We have the ability for mobile users and remote users in these remote networks to reach any network within a single hop. So the idea is that we have this meshed cloud infrastructure across all the different connections and all the compute regions, if we're talking about a global solution here. And we use dynamic routing and VPN tunnels among all these different cloud nodes, so that your mobile user SPNs, your portals, remote network SPNs, all route traffic through their geographically closest SCCAN. We can access other service connection corporate access nodes if we need to. And we're going to talk about a lot of these examples that we can use and a lot of ways we can control this and override, say, the basic functionality when we're doing this. Now, a lot of this is predicated on having the proper licensing in order to have these different options available. So let's spend just a moment talking about the licensing for Prisma Access. So we have licensing that involves just the remote network SPNs, the RN SPNs, or these branch offices, these storefronts, these places where it doesn't make sense to have an on-premise firewall and you don't have the resources for an on-premise admin to be able to deploy these and manage these. And that's the business and business premium. Big difference between these is with business premium, we have threat protection and wildfire. And the basic level business licensing does not. Now it still has security policy rules. It still has URL filtering. It still has DNS security. But we don't have the threats and viruses and wildfire. So you don't have security profiles other than URL filtering. We have another license that is strictly for mobile users. That's our ZTNA, or Zero Trust Network Architecture offering, which means I don't have remote networks. All I have is mobile users. Users sit at home, and I want to be able to protect them. And again, we do URL filtering and threat prevention with them. DNS security is not part of that. Now, there are a couple of different add-ons we can do. We can have service connections with the ZTNA. It comes with 2 if you're regional, or what we call local, and 5 if you're doing worldwide. And you can also add other ones on. We can do data leakage protection and ADEM, Autonomous Digital Experience Management, to be able to closely monitor your mobile users, and be able to look for trending and issues and things like that. The last licensing scheme we have is enterprise. So it's everything. I got my remote users and my mobile users. I've got all my threats and wildfire and URL filtering and DNS security, and the ability for every add-on we have. And one that's very important is Interconnect. So some of the examples we're going to be talking about are going to involve Net Interconnect, the Net Interconnect add-on. Well, by default, a user in a remote network or a mobile user is going to be able to go through a service connection to reach a data center for, as I said, say, authentication or an internal DNS server or whatever the case may be. And they're going to be able to go out to the internet. And the same would be with a user in a branch office. Again, they can go down to service connection if you are licensed for one, for whatever service they might need, and they're able to go straight out to the internet. If we add Interconnect, the Net Interconnect add-on, now we have the ability for a mobile user to be able to reach a user in a branch office, or a resource in a branch office, or a remote network, an RNSPN, or a user behind an RNSPN, or have branch-to-branch connectivity also. So this would require you to have the enterprise licensing as well as the Net Interconnect add-on. So depending upon your licensing levels, you have these options available. So let's talk about some of these options that now are available to you. First of all, if we have the Net Interconnect add-on and we have the enterprise licensing, then we have the ability to have remote network to remote network connectivity. So, I have a user in one branch office that needs to talk to a user in another branch office. Now we can use Prisma Access to do that. So when traffic is sent through Prisma Access from one remote network to another remote network, our internal dynamic routing determines the best route and is going to forward the traffic to that destination remote network security processing node. And this has the full mesh design. It's designed to reduce latency between the remote networks and give you highly reliable availability of all the remote networks. Because remember, these SPNs are actually in high availability pairs. If you have the enterprise licensing without the interconnect, you do have the ability to have SCCANs, or Service Connection Corporate Access Nodes, SCCANs. This gives you the ability to have services on the ground in a data center that might be needed by branch office users, maybe most likely to authenticate. I've got a user here in a branch office that wants to go out to the internet, and I need to authenticate him using SAML or something. So that would go back to an existing authentication scheme in an existing data center. And again, we're using dynamic routing between these SPNs and these CANs, these service connection CANs, corporate access nodes, and secure VPN tunnels, even within regions and around the world if you have the global licensing. The remote network's automatically going to use the closest corporate access node, the closest service connection, SCCAN. There's no additional configuration to do that. So if I did have multiple service connections, it's going to use the closest one. If you just have the business or the business premium licensing, then you don't have those service connections. And the only reason they'd be required again is if there's something back at a main data center that is required to be accessed by a user in a remote network, a branch office. Otherwise, those users would just go straight out to the internet. And maybe they have some sort of local authentication scheme where they don't have to reach out to an existing on-premise data center in order to authenticate. An interesting thing about mobile user traffic. So again, I have a user sitting at home connecting to an MUSPN, a mobile user security processing node. If you think about our traditional on-premise solution for Global Protect, we have the idea of Global Protect portals and gateways. An MUSPN runs PAN-OS, just like an RNSPN does. And if you are familiar with the idea of a gateway, a Global Protect gateway, similar functionality with an MUSPN. So a mobile user connects to an MUSPN, and we do have the ability, if you have the Interconnect, Net Interconnect add-on with the enterprise license, for a user to go through an MUSPN and connect back to a user in a branch office or a remote network going through an RNSPN. But these mobile user SPNs are designed to send traffic directly out to the internet. So we need some way to redirect our user to a different direction. And we use a corporate access node, service connection corporate access node, to act as a router to forward mobile user traffic to these different remote networks. Typically, a corporate access node is for a service connection in order to allow access to different services that are needed in an existing data center. But the idea is we can actually have another separate use case for these corporate access nodes. So again, if you have multiple service connection corporate access nodes, mobile users are going to use the closest one to them, just like our remote network users did. Here's an example to sort of illustrate why you want multiple service connections, multiple corporate access nodes. Let me be specific, there are corporate access nodes. Let's say you have the global licensing. We've got enterprise licensing, we've got net interconnect, so we've got the whole thing here. And you have a main data center, maybe with a backup, but they exist in one region here in North America. But you have users all over the place. Maybe I've got users in Europe or Asia or whatever the case may be. If they need to reach some sort of service or authenticate in a different region, they're going to travel through Prisma Access, go down the service connection and get to their, say, Active Directory server, Radius server, whatever the case may be. But remember that this service connection also, or this corporate access node, also acts as a router. So if I had a situation where I had a mobile user sitting in, let's say Munich, because we're in Europe here, and they need to talk to somebody in a branch office in Frankfurt or in Paris. Well, remember that corporate access node acts as a router. So if the corporate access node is halfway around the world, then anytime we need to forward to this branch office that's close by, we have to go halfway around the world to that router, to that corporate access node in order to figure out how to get there. Well, that's going to add latency, and it's not going to be a very friendly user experience. Wouldn't it be easier if I could just go from my MUSPN to that user in the branch office? Well, yes, it would be. So what we can do is we can deploy a corporate access node within that region, within Europe in this case, just to act as a router. Even if there's no service connection with any sort of data center at the bottom or any sort of services that need to be reached, we can just deploy this as a router. And remember, with the global licensing, you get 5 of them anyway. So this would be a good use to reduce latency and allow regionalized local access to local stuff. So that's a great way to reduce latency. So that's sort of some of the default routing functionality. But let's move into some of the advanced stuff. Routing modes, traffic steering, that sort of thing. Now, Prisma Access supports 2 different routing modes for service connections. Again, if you're licensed for these service connections. Our default, or what we call cold potato routing, or Prisma Access, is going to use dynamic routing and best path selection without adjusting any sort of BGP attributes to deliver traffic through the best RNSPN or SCCAN for delivery into the customer's network. The second option is what we call hot potato routing. In this case, Prisma Access hands off traffic as quickly as it can into the customer's network to try to get the session down the closest corporate access node. We use corporate access nodes because they are not metered and not rate limited. Whereas remember, a security processing node is rate limited to 500 megabits per second, or that's our SLA anyway. Whereas the corporate access nodes aren't. So you can use this method if you want to get down to your customer does, or you do, your organization's existing routing infrastructure, maybe BGP infrastructure, and you want that to do the majority of the routing decisions, because maybe you feel that that's the better option to move traffic to its destination. When you onboard or configure RNSPNs or SC cans, you have the ability to either use static routing, or when you onboard a security connection with a corporate access node, you have the ability to join a BGP AS. We have our own default one that we use for our internal and eBGP, BGP, but we can join in with the customer's existing one, or we can use static routes. So let's look at the difference between cold potato and hot potato. Oh, and by the way, if you want to choose hot potato, you simply go to the advanced tab when you're onboarding a service connection, and there's a drop down for default and hot potato. So the default routing, again, we're going to use our routing infrastructure, our Prisma Access backbone, as long as possible to get from one site to another. So in this example, let's assume we have a mobile user hitting a MUSPN here in blue, and they need to talk to a user in a remote network in Europe. These pink things are going to be RNSPNs or SC cans, and these blue things are going to be MUSPNs or RNSPNs. So the default behavior is that if I've got a user and sitting at home trying to reach somebody in an office in Europe, I'm going to hit my MUSPN. I'm going to route through the Prisma Access backbone to the closest place to that, say that RN SPN, down to my user on the ground. And then, of course, the return traffic is going to follow the same path. That's cold potato. That's our existing or our default routing option. Now we use, again, our own internal BGP. If you have a lot of different routes configured, then what we do is we break those routes into blocks of /24 subnets, so Class C subnets. And if you're using our default AS, then we have our own AS number, but we actually differentiate between the different service connections that might be available, one in the US, one in Europe, one in Asia, etc., by using a additional add-on, an additional value, what we call a community value, to differentiate the different service connections. Here's an example of one, and you can see what it looks like if you were to go to your cloud services status and you click on the network details tab, you go to your service connection and you open it up and you go to the show the BGP status and go to the peer. You can actually see our BGP AS 65.534 and the community string 63.033 there, which designates what service connection this route belongs to. Hot potato routing The idea there is we want to push traffic off to the nearest service connection, get it down into the customer's network, let the customer's network forward it to where it needs to go. So in this case, again, I got my mobile user sitting in the US trying to talk to somebody in a remote network, in Europe. So they go through the MUSPN, down the nearest service connection, through the customer's network, outside of Prisma Access, hits that destination, and of course, the client responds back, and it follows the path back. So we are, instead of using the fiber optic Prisma Access backbone, we're pushing things down to the customer's network as soon as possible. It only uses service connections in order to do this because they are unmetered. Last thing I want to talk about a little bit is traffic steering. Again, if you are familiar with policy-based forwarding with our on-prem firewalls, that's part of this solution, or a similar functionality. Let me put it that way. We have the ability to have several different ways to control traffic. It gives you better flexibility. And one of the reasons for this is to help with a stepped migration to Prisma Access. You may have customers, or you may be a customer, that says, I really need to expand my mobile user solution. So I need these SPNs and my portals and things like that, because all of a sudden I have a flood of mobile users that I didn't have before. And I don't want to put in the capital expenditures and all those sort of things for bigger physical firewalls and bigger ISPs and stuff like that. I'm going to go with Prisma Access. But a customer like that may not have Palo Alto Networks firewalls or experience with them. They may use another vendor. They may not have gone through the process of determining what sort of security policy rules and decryption and threat protections that they might need, but they could have an existing security stack back at an existing data center, maybe a different vendor, maybe us, maybe they haven't migrated their configuration yet. Maybe they haven't made those decisions. They're trying to quickly adopt the mobile user solution, or maybe even the remote network solution, but they haven't, or they haven't had the opportunity or taken the opportunity to deploy security policy rules out to all these different Prisma Access nodes. Well, we can override the default routing and behavior of Prisma Access, which would typically go through a security processing node for a mobile user and out to the internet, or down a service connection to a service, and then again through an MUSPN out to the internet. We have a couple ways we can override that behavior and actually push that mobile user traffic or a remote network user through a service connection down to an existing firewall or security stack, and then out to the internet based on however traffic from that data center might get out to the internet. So not through Prisma Access. We use Prisma Access to get the stuff to the data center, and then let the security stack, the devices at the data center, inspect the traffic instead of our security processing nodes. This will give the customer a way to easily, quickly adopt Prisma Access, and then take time to work into adopting security policy rules, threat protections, all those sort of things that we have with Prisma Access. And we do this two ways. Default route traffic steering. So the idea there is that we can use a default route to push all traffic down a security connection, corporate access node down a security connection, a service connection, I'm sorry. Do an existing security stack on the ground and inspect traffic there and then send out to the internet outside of Prisma Access. Or we can use traffic forwarding rules, which then allows us to designate exactly which traffic we want to send in a different direction instead of everything. And you can use a combination of these. So the idea is a native routing remote network users going through SPNs or mobile users going through the MUSPNs are going to route the traffic that's bound to the internet directly out to the internet. We can use default route traffic steering to send traffic to one or more different service connections rather than out to the internet. So normally we would ignore any sort of default routes, but now we can pay attention to those. And then with our traffic forwarding rules, similar to what you would think about with your policy-based forwarding rules, we then have the ability to select traffic that we want to route in a different way and route everything else the normal way. Now, if we use a combination of these two things, the default route traffic steering, our native traffic steering, and the traffic forwarding rules have the highest priority, then the default routing, then the native routing. So a couple of examples. Let's say the normal traffic pattern, and this is the normal traffic pattern for a mobile user trying to get out to the internet, is that they're going to go through the MUSPN, mobile user SPN, out to the internet. Now they may use a service connection to authenticate or whatever the case may be, but to get out to the internet, they go through the security processing node. Well, again, let's say we have a customer that's deployed these MUSPNs for their mobile users, but they've yet to add any security policy rules. However, back at headquarters, they do have a firewall. Maybe it's a different vendor, maybe it's ours, maybe they're just required to track or record user traffic, and so they need it for some reason to come back here. Well, we have the ability to add a default route, which would push all traffic back down a service connection to a data center where there's some sort of existing tracking or security, and then it follows however that device would get it out to the internet. So it doesn't use our native routing. We're using a default route to push it down a service connection, or it could be the closest service connection. Maybe we have several options available. Traffic forwarding rules, we have the ability to be more granular about what we want to do. So we can look at source IP addresses, including EDLs, external dynamic lists. user IDs, destination addresses, including EDLs, URLs, and custom URL categories, but not our predefined URL categories, and service types, which are port numbers. And we have the ability to basically define different service connections and group them together to say these are my targets, and then create these policy-based forwarding rules with that source and destination information, and either forward directly to the internet or forward to whatever target, whatever service connection groups that we have created. That's done under the service connection setup, and we have their traffic steering rules. And that's where we set all this up. So this allows us to do some pretty cool stuff. So again, we have mobile users, for example. And by default, to get out to the internet, they would go through an MUSPN and out to the internet. But we do have the ability to re-steer traffic in a different direction using the default routes, which would push it through down to a data center and then out to the internet. And we have the ability to do things like exempt specific URLs and things like that with our traffic steering rules to send them a different way. So we say, well, go down to the existing security stack in a data center, and unless it's Office 365, then we need to bypass that because maybe it breaks it or something. So then we can use traffic forwarding rules to make those decisions, because our default route is going to take secondary precedence over our traffic forwarding rules. Traffic forwarding rules are going to override the default routes. So then we have the ability to sort of build upon this and have the idea where we're going to have different traffic splitting off, going in different directions based on the default routes, traffic forwarding rules, and exceptions to that with the forwarding directly to the internet. As I mentioned before, if anybody does have any questions, we do have a Q&A section here, and please feel free to ask any questions you might have. But as far as my discussion here, we're done. But I'd like to hang around and answer any questions that anybody might have. So what we'll do is, if you have no questions or don't want to hear any discussion or anything, feel free to jump off the call. And I appreciate you coming and listening. And hopefully you learned something. Hopefully this has been worth your time. We do record these and make these available. So if you have coworkers and things like that you think this would be valuable for, that couldn't make the live call, we will record this for everybody, and you'll be able to view it offline later on. But again, if there are any questions, comments, or things like that, I'm going to hang out for another minute or two in case there are.